Lesson 18-4. Number 1, it says, graph the data, roughly fit a sign model of the form y equals a times sine 1 over b times x minus h plus k to the data and graph the model on the same grid as the data. 2, obtain a sign regression model using a graphing calculator and then visually compare the two models in relation to the data. Okay, so here we have, the table gives the average monthly temperature in Nashville, Tennessee in degrees Fahrenheit. So this is month 1, 2, 3, 4, and so on. So let's go to our calculator. We're going to go menu, add lists and spreadsheets. So here I'm going to just put month. M-O-N-T-H. Where did it? T-H. And then we'll go down and it's 1, 2. And we got to 12 months. And then in column B, I'm going to put temp, T-E-M-P, for temperature. And then we'll see what we had here. 37.7, 41.7. All right. 50, 59, 67.5, 75.7, 67.5, 75.7. 79.4, 78.7. All right. 71.5, 60.3. 11 is 49.8 and 40.4. 49.8 and 40.4. And 40.4. All right, good. Now we can graph this, and we'll graph it like so. We'll go on, graph. And down here we'll put month, that's our independent variable. And on here we'll put temp, our dependent variable. And that's kind of what it looks like. Not a problem. So what do we got here? All right, graph the data roughly. Okay, now we need to roughly fit a sign model of the form. Okay. Let's go back to our graph. We're going to go menu, 4 for analyze, 6 for regression, and then A for sign model. And there it is. So y equals 21.02. Y equals 21.02. Sign, and that was 0.5. So you write it like this, 1/2 times, and then you got x minus 2, so 0.5x, put it like this, 0.5x minus 2.01, 2.01, and move that over a little bit. 58.61. 58.61 plus 58.61. Now, that's not exactly like that right there. We got to get rid of the 1/2. So to do that, we'll multiply this in here by 2. So we'll have y equals 21.02 sine, and then that's 2, and that's going to be x minus, and if we multiplied all of that by 2. All right. So that gives us x minus 4.02 and then plus 58.61. So now we have it like that. Now we have it like that. All right. And then visually compare. All right, so there we go. There's our equation. And then it had some steps down here. I guess I didn't actually follow them. Number 2, the table shows the approximate U.S. residential monthly electricity consumption in billions of kilowatt hours for 1 year, where x equals 1 is January. All right, so we're going to do the same thing. We're going to do the same thing we did before. So we got month, and then we're going to have consumption. Let's go back to our calculator. And I'm going to clear all this out so it doesn't, when I'm putting stuff in, it doesn't confuse everything. All right, we'll go here. We'll put month. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Up here we'll put consumption, so I'm gonna consumption, and then what did we have? This will take a little bit longer. So what do we got? 136, 116. 106.91, 91, 94, 114. I think the other one was 137. We'll check it. 138, 115. 115. I think the next one was 98. We'll see if that was right. 150, 92, and 124. All right, so we got all of that. What's our next step? To graph it. On, graph, and down here at the bottom, our independent variable is month. Our dependent variable is consumption. And that's what it looks like. Now to draw our curve, menu, 4 for analyze, 6 for regression, A for sinusoidal, and there we go. All right, so let's go back here. And our curve is y equals 22.55 sine and 0.99. I'm going to say 1x plus 0.54. 1x plus 0.54, and then plus 114.2 plus 114.2. All right, and there's your equation. On this other one here, I'm fine with you leaving it like this, but you on a test you might see it like that, and if none of yours match, then you might need to do something like this. But I'm fine either way. We good? Let's try number 3. And we're going to do the same thing we did before. We're gonna graph. The table shows the amount of daylight in minutes from sunrise to sunset on the 21st day of each month in Green Bay, Wisconsin. All right. So 21. Okay. That's going to be a little bit different. Day of the year. We might want to, well, we'll do it like that. We can do it. It'll work. Let's go to our calculator. And we'll, again, clear it out. New document. No. Spreadsheet. And then we'll say this is day. And I think the first one was 55. Let's see if that was right. Oh, no, 21, 52, 80. 21, 52, 80. 21, 52. I wasn't even close. Oh, what did I do there? On, new document, listen spreadsheet. We'll put monthly. No, it was day. 21, 52, I think it was 80. 21, 52, and 80. 21, 52, and 80. 111, 141. $172, $202. $233, $264. I got a little happy with the threes there, didn't I? $264, $294, $325. Did I skip one? 21, 52, 80, 111, 141, 172, 172, 202, 233, 264, 294, 264, 294, 325, 355. And then, what do we call this? Daylight. We'll put it in minutes. Okay. 565, 646. $732, $826. $901, $933. $826, $733. 643, 643. Did I skip one? I must have skipped one. Let's go back up here. 565, 646, 732, 826, 901, 933, 902, 902, 826, 733. $643, 563, and 530. Okay, that worked out. Make sure our cursor is back in our on graph. Our independent variable is day, and our dependent variable is minutes. And it looks sort of like that. Menu 4, 6 for the regression, A for the, and there we go. So we got y equals, let's see, y equals 197.76, 197.76 sine 0.017x minus 1.32 minus 1.32 plus 728 point, I think it was 68. It was 68. Okay, for about how long each year is a minimum daylight at most 6 or at most 10 hours? Well, that would be 10 times 60, which would be 600. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 months. 9 months. Not too bad. Good job, folks. I hope you have a wonderful evening, and I'll see you later.